Welcome to episode 16 of Omni Eyes. Have you ever wondered how to spot hidden enemies within the absolute darkest night? When visible light drops to absolute zero, finding your way seems impossible for humans. But nature always provides a brilliant solution. Deep inside the dense, shadowy jungle, a legendary predator silently waits, mastering the darkness with an incredible, terrifying biological advantage. Meet the pit viper, a remarkable creature that possesses an extraordinary secret weapon designed specifically for hunting in pure darkness. They do not rely solely on their standard vision to navigate the perilous night, or to track down their elusive prey. Instead, they possess specialized pit organs situated perfectly right between their eyes and nostrils, functioning as highly advanced biological sensors. These unique facial pits are not ordinary eyes. They are incredibly sensitive biological infrared receptors designed to detect minute temperature shifts. While human eyes can only process visible light, the pit viper actually perceives the invisible thermal radiation emitting from living bodies. In the world of modern surveillance technology, this exact biological concept translates directly into what we call thermal imaging systems today. Military forces and elite security units utilize this advanced thermal technology to locate hidden personnel and concealed objects during night operations. Thermal cameras easily pierce through pitch-black darkness, thick fog, or dense smoke, revealing targets that normal optical lenses completely miss. The pit viper does not merely see the physical shape of its prey. It actually visualizes the pure, radiating life energy. This biological thermal detection allows the snake to strike with deadly accuracy, even when the environment is completely devoid of light. The combination of regular vision and thermal sensing creates a highly sophisticated, overlapping visual map inside the viper's complex neural network. This dual-layered perception acts exactly like modern security cameras, utilizing artificial intelligence to identify specific targets based on their heat signatures. Imagine walking through a pitch-black forest. Your eyes see nothing, but a thermal sensor reveals a glowing, vibrant world of life. Every warm-blooded creature stands out like a bright beacon against the cooler background, making camouflage practically useless against thermal detection capability. The crucial lesson we learn from the pit viper is simple. Never completely trust only what your naked eyes can perceive. In the highly competitive realms of professional security and advanced photography, expanding your observational spectrum is absolutely vital for ultimate success. Shifting our focus from standard visible light to the infrared spectrum provides a massive tactical advantage in any challenging observational environment. Have you ever seriously considered attaching a thermal sensor to your personal camera gear to capture stunning, unprecedented night wildlife footage? By adopting this technology, filmmakers can document nocturnal animal behaviors without disturbing them, with bright, unnatural artificial lighting systems at night. Let us dive deeper into the microscopic anatomy of the pit organ to understand how this biological marvel actually functions perfectly. A thin, highly innervated membrane hangs suspended inside the pit cavity, reacting instantaneously to the faintest infrared radiation from nearby sources. When a warm mouse approaches, the infrared waves hit this sensitive membrane, triggering an immediate electrical signal to the snake's brain. The brain processes this thermal data alongside visual input, creating a perfectly synchronized image that highlights the prey's exact spatial location. This biological processing speed is incredibly fast, allowing the snake to launch a lightning-quick strike before the prey even registers danger. Engineers have spent decades attempting to replicate this exact level of speed and precision within our artificial thermal imaging camera sensors. Early human thermal cameras were massive, requiring heavy cooling systems to function, unlike the viper's naturally efficient, room-temperature biological sensing organs. Today, thanks to microbolometer technology, we have successfully miniaturized these thermal sensors to fit inside small drones and handheld mobile devices. These modern microbolometers absorb infrared radiation, changing their electrical resistance to create a detailed temperature map of the entire viewed scene. Just like the viper's brain, our advanced software translates these electrical changes into a colorful visual display we can easily understand. Red and yellow colors typically represent warmer objects, while blue and purple shades indicate cooler areas within the generated thermal image. This false color mapping allows humans to instantly recognize heat signatures, effectively giving us the pit viper's extraordinary superpower in the dark. In search and rescue operations, a thermal drone can easily spot a lost hiker hidden beneath a dense canopy of trees. Firefighters utilize handheld thermal imaging cameras to navigate through smoke-filled buildings, locating trapped victims and finding the hottest fire source quickly. Medical professionals even use thermal imaging to detect abnormal blood flow and inflammation within the human body, without any invasive procedures. The applications are truly endless, proving that looking beyond the visible light spectrum opens up entirely new worlds of vital information. Let us return to the dark forest and witness a simulated hunt from the unique dual-spectrum perspective of the pit viper. The night is completely silent. A small rodent scurries across the dry leaves, perfectly camouflaged in the shadows to human eyes. But to the waiting viper, the mouse is a glowing, vibrant entity, radiating a beautiful, undeniable aura of warm life energy. The snake slowly coils its muscular body, calculating the exact distance and trajectory using its highly precise stereoscopic thermal sensing capabilities. With explosive speed, the viper strikes the glowing target, demonstrating the absolute lethality of combining thermal detection with raw predatory instinct. This flawless execution in complete darkness showcases millions of years of evolutionary perfection, resulting in the ultimate nocturnal biological hunting machine. Human engineers constantly study these biological masterpieces to improve our own artificial sensors, aiming for greater sensitivity and faster processing speeds. The concept of biomimicry, taking direct inspiration from nature's designs, has led to some of the most significant technological breakthroughs ever. By analyzing the pit organ's membrane, scientists hope to develop new, uncooled thermal sensors that are even smaller and more efficient. Imagine a future where every smartphone is equipped with a high-resolution thermal camera, inspired directly by the biology of the viper. You could easily check your home's insulation, find a lost pet in the dark, or diagnose a fever instantly at home. The line between biological evolution and technological innovation continues to blur as we unlock the profound secrets hidden within the natural world. The universe is filled with countless forms of energy and radiation that remain completely invisible to our limited human sensory organs. Visible light is merely a tiny fraction of the vast electromagnetic spectrum that constantly surrounds us in our daily modern lives. Infrared radiation, ultraviolet light, radio waves, and gamma rays constantly interact with our environment, completely unnoticed by our standard human perception. To truly understand the universe, we must build specialized tools that translate these invisible energies into formats our brains can comprehend. The thermal camera is one such magical tool, revealing a hidden dimension of heat transfer and energy flow in real time. When you look at a seemingly cold, lifeless concrete wall through a thermal lens, a completely different, vibrant story suddenly emerges. You can see the lingering heat signatures of people who leaned against it minutes ago, leaving invisible, glowing thermal handprints behind. This residual heat detection is incredibly useful for forensic investigators trying to reconstruct events at a crime scene after the fact. Law enforcement officers can determine if a parked vehicle was recently driven simply by looking at the glowing heat of its engine. They can even spot freshly disturbed soil where something might be buried, as the thermal properties of the earth change drastically. In the realm of wildlife conservation, thermal imaging has revolutionized how researchers track and study endangered species in the natural habitats. Counting nocturnal animals like bats or owls used to be incredibly difficult, relying on intrusive spotlights that altered their natural behaviors. Now, conservationists use thermal drones to quietly survey animal populations from high above, gathering highly accurate data without causing any disturbance. This non-invasive monitoring technique provides vital insights into animal migration patterns, breeding habits, and population health, aiding crucial global conservation efforts. Let us take a moment to appreciate the incredible journey of a single infrared photon traveling from a warm object's surface. This tiny packet of thermal energy radiates outward, traveling through the cold night air until it finally reaches a sensitive detector. Whether that detector is a biological pit organ or a silicon microbolometer, the ultimate result is a profound transfer of information. Information about presence, vitality, and energy is instantly conveyed across the darkness, bridging the gap between the observer and the observed. The pit viper understood this fundamental language of heat long before humans even realized that the infrared spectrum actually existed globally. They are the original masters of thermal warfare, utilizing their evolutionary gifts to dominate their ecosystem in the absence of light. As we continue to develop more advanced artificial intelligence systems, the fusion of different sensor data becomes increasingly critical for success. Autonomous vehicles, for example, cannot rely solely on standard optical cameras to navigate safely through complex, highly unpredictable nighttime driving environments. By integrating thermal sensors, a self-driving car can instantly detect a pedestrian crossing the dark road, long before the headlights illuminate them. This multi-sensor approach mimics the Viper's brain, seamlessly blending visual and thermal data to create a comprehensive, highly accurate environmental model. The future of artificial perception lies in this exact kind of sensory fusion, expanding our machine's ability to understand the world. We are essentially giving our technology the evolutionary advantages that nature spent millions of years perfecting in incredible predators like the viper. Photography enthusiasts, consider the creative possibilities of exploring the thermal spectrum to capture unique, surreal perspectives of everyday objects and landscapes. A simple cup of hot coffee becomes a glowing, dynamic masterpiece of energy transfer when viewed through a high-quality thermal lens. The human body transforms into a beautiful, abstract canvas of vibrant colors, highlighting the complex circulatory system pulsing just beneath the skin. Thermal photography challenges our traditional understanding of aesthetics, inviting us to find beauty in the invisible forces that shape our reality. It reminds us that reality is multi-layered, and what we perceive with our naked eyes is just a small, limited fragment. The pit viper teaches us to look deeper, to sense the underlying energy, and to adapt to the challenges of the dark. In a world where information is power, expanding our sensory horizons is the ultimate key to survival, innovation, and continuous progress. As we push the boundaries of modern science, we must always look back at nature for brilliant inspiration and elegant solutions. The elegant simplicity of the pit organ stands as a profound testament to the incredible, limitless power of natural biological evolution. It is a perfect, self-contained thermal imaging system that requires no batteries, no heavy cooling fans, and no complex software updates. While our technology is undoubtedly impressive, it still pales in comparison to the efficiency and reliability of millions of years of evolution. Perhaps one day we will fully bridge the gap between biology and technology, creating artificial sensors that are truly indistinguishable from life. Until then, we will continue to study, admire, and learn from the extraordinary creatures that share this beautiful, complex planet with us. The dark night holds many terrifying secrets, but with the right tools, it also reveals a world of breathtaking, hidden wonders. Whether you are a security professional, a wildlife filmmaker, or simply a curious explorer, the infrared spectrum offers endless, exciting possibilities. Equip yourself with the knowledge of the viper, and you will never look at the shadowy darkness the exact same way again. The glowing heat signatures of life are always there, waiting patiently to be discovered by those who dare to look beyond light. Embrace the unseen energy, harness the incredible power of thermal imaging, and elevate your understanding of the complex natural world around you. Technology and nature are not opposing forces. They are deeply interconnected branches of the same magnificent tree of knowledge and discovery. By studying the biological marvels of the animal kingdom, we unlock the profound secrets to advancing our own human technological capabilities significantly. The pit viper's thermal vision is an extraordinary example, showing how nature has already solved many of our complex modern engineering problems. As we prepare to conclude this fascinating exploration of thermal perception, let us reflect on the profound lessons we have learned today. The invisible world of heat is a dynamic, ever-changing landscape of energy that connects all living beings in a continuous, glowing web. We encourage you to seek out new perspectives, experiment with advanced imaging tools, and always question the absolute limits of human perception. Share your thoughts and experiences with thermal photography in the comment section below, and join our growing community of curious visual explorers. Have you successfully captured any stunning infrared images recently? We would absolutely love to see your unique creations and discuss your techniques. Thank you for joining us on this illuminating journey into the dark, hidden world of the pit viper and advanced thermal technology. We hope this episode has inspired you to expand your vision and explore the invisible forces that shape our beautiful, mysterious universe. This is Omni Eyes, episode 16. Stay curious, keep exploring the unseen world, and we will see you in the next video.